Hello, folks. I'm Nathan, and in today's video of Foundation Library, we'll be learning about how to check if your query is using an index optimally or not. First, we need to understand when do we say a query is optimal. So, any JCR query can broadly be divided into various restrictions. What are they? They can be node type restriction. All my resultant nodes should be of type this. These can be property restrictions. All my resultant nodes should have this property value as this. Then there can be path restrictions. All my resulting nodes should be under this particular path. And then there's always sorting. If all these restrictions and the sorting are being handled by the index, Lucene or Elastic, then we say that the query is optimal. However, if that's not the case and either of these restrictions or the sorting are not being handled by the index, then that task falls upon the query engine and it does that later on in memory and thus making the query suboptimal. Now, how do we analyze whether a query is optimal or suboptimal? We have a query performance tool in AEM that helps us do that. It is present at this particular endpoint, and now we'll go through a set of sample queries to see how it works. Under this explain query tab, we'll select whatever language our query is in, paste the query over here, and then simply do explain. So our first query is get me all the nodes of DAM asset type where DC format is equal to foo. I do explain. It shows me that the index being used is DAM asset Lucene 11, and here is the execution plan. The most important part to see over here is the Lucene query part, where it tells me which of the restriction is being served by the index. So as we can see, our query just had one property restriction on DC format being equal to foo, and that is being served by the Lucene index, and hence this query is optimal. Now, moving on to the next query. We have this query get all the DAM asset type nodes where DC format is foo and order it by DC title. We do an explain and we can see that the Lucene index serves the property restriction as well as the sorting. So both the restrictions are being served by the index and hence the query is optimal. Now the third query, the restrictions are property restriction on DC format, then this is your path restriction, and then this is ordering. Now we do explain, and we can see that two of these restrictions are being served by the index, the path restriction and the property restriction. However, we do not see the ordering or the sorting being served by the index over here, and hence the query is suboptimal. What would happen in this case is the index will give me all the nodes under content slash content where the property DC format is equal to foo, but the sorting would then be done by the query engine in memory and thus making the query suboptimal. Now, moving on to the next query. I have two property restrictions over here, one on DC format being equal to foo and another one non-index prop being equal to bar. I do explain, and as we can see, the Lucene index is only serving one of these properties. What would happen in this case is I'll get all the resultant nodes where DC format is equal to foo, and then the query engine will traverse through all of those nodes and search if the non-index prop is equal to bar or not. Such a query can be very slow if we have, let's say, thousands of nodes that have DC format is equal to foo, but only one of those nodes that has non-index prop is equal to bar. If both of these were being served by the index, it would have been very fast. But in this case, the query engine would traverse all those thousand nodes where DC format is equal to foo to check or find the one node that has non-index prop is equal to bar. And thus the query would be suboptimal. Now, the next query is a full text query where we get all the DAM asset nodes in which the property DC format contains the word foo. I do the explain and I can see the full text condition on the property DC format is being fulfilled by the Lucene index, and thus this query is as optimal as it gets. Now, moving on to our last query, we are getting all the DAM asset type nodes where the property CQ tags contains foo. Now, this is another full text property. And if I do explain, I can see no index is getting used. That means there is no index in the AIM repository that can do a full text search on the CQ tags property. And hence, this query is very, very slow and thus suboptimal. Now we need to understand that even a suboptimal query can perform well if the content of the environment is very less and the query engine can easily manage traversing through that content. However, we start hitting problems as the content in the repository grows. So we need to be sure at the time of writing queries that they are using an index effectively or not, and that we can do using the query performance tool. Otherwise, what would happen is that initially we would not feel the pain, but as the content grows on the repository, we'll start seeing that the query is suboptimal and start giving you performance issues. Now, how to actually fix the suboptimal queries? We'll cover that in the next video. Till then, I hope you enjoyed this one. Thank you.